Hello, I'm Diane Harris Klein. I'm a professor in the history department and also in the program in classics at George Washington University. I have been a professor for about 30 years now. And in 2010, I began to experiment with social network analysis in the study of my historical field, the ancient Greeks. So using social network analysis to understand the relationships and dynamics in these different societies of the past is a field called historical network research, and I've been involved since the beginning in the development of this field. So I'd like to share with you a little bit about what we're doing and what I've done and what I hope you will be able to do by the end of this session. Let's go ahead and move forward. So, as you will learn, social network analysis maps relationships and transactions between people and groups or other kinds of entities. In my field, often we're using archaeological artifacts and their relationships in space and geography. What we're interested in are three levels: looking at the whole network, looking at the clusters or other kinds of units inside the network, and the role of the individual. For historical network research, we often say that the first example we have is from 1993, studying the economic and marital ties in Renaissance Florence. However, in my research, I've discovered one even earlier in 1990, where Alexander and Danowski talked about the letters of Cicero and the relationships between the knights or equites and the senators. On the right, a very important dissertation and then publication came out in the late 2000s. Sean Graham published on these brick stamps that you see in the lower right. They're embossed labels, kind of, brand names for different families that were manufacturing bricks to build structures along the Tiber River near Rome. And so he looked at those kinds of relationships, and you can see in the publication that he is using formal social network analysis. Now, more often, people studying Greece and Rome are using network thinking. That is, they're talking in network terms and using these terms, but they are not actually studying material that's quantifiable. So on the left, Josh Ober in 2008 published Democracy and Knowledge, and this image is a kind of thought piece on how he thinks these different parts of the city-state of Attica were related, but it's not actually based on quantifiable data, and they did not use programs like NodeXL. On the right, too, is very important. First published as a journal and then as a book, Greek and Roman networks in the Mediterranean. And this is the most sophisticated figure in the whole book. Finally, Irad Malkin, who was an editor of that last thing, wrote A Small Greek World in 2013. And this is an extraordinary piece for any of you studying any period of historical network research. This is a great book to read, and it has no formal social network analysis in it. I'll talk about small worlds later. It's of great interest for those of us who are studying communities. So I was looking around in 2010 for some software to use to begin my analysis of Athens, of Athenians 2,500 years ago. And NodeXL seemed particularly friendly for people like me in the humanities. I know how to use a spreadsheet, and I began to play with it. Of course, it is designed for macro data like this, where we have these huge numbers in the statistics, and they're based in the real world, in the present world, and also in social media, the world of the connected present. And I'm looking for something to use to find the connected past. So I began to play with it and work with it. And this was my very first experiment. I took a short piece written by a Roman named Plutarch, who did a biography of Pericles, the great statesman of the mid-5th century BC in Athens. So this was my first experiment, and I went actually to the University of Maryland, and I talked with Ben Schneiderman, who was one of the developers of NodeXL, and I asked him, "Am I doing this right? And does this make sense? And what should I do with it?" And he gave me such great advice, which was start with proving something that people think in your field, being able to show, to demonstrate that it is true, or conversely, that it is not true. But so I began to think, well, women tie families together. In ancient Greece, you trade off your daughters in order to get some sort of transactional benefit with that other family. And here I was able to show that. At the same time, we have the development of a larger community in the world, starting mainly in Europe, with people who are interested in all these periods, like the Medicis in Renaissance Florence, or the brick stamps of Rome, and my work in Greece. People who are interested in all these earlier ties and communities. So the Historical Network Research Group began to have conferences, and the very first conference, as you can see at the bottom of the right, was in Hamburg in 2013. That's how new this field is. In 2014, it was held in Ghent in Belgium, and I went to that, and in fact, I was a keynote speaker for my work then on the social network of Socrates. I did not go to the others except for Luxembourg in 2021, where I gave a paper with a friend on the social networks of the potters and painters, of those Greek vases that are so famous. I'll talk to you about that later. My first work that was published, let's say, was the study of Alexander the Great. And if I had it to do over again, I would probably pick something a little less ambitious. This was a very large network for me to practice on, so to speak. But I do give very specific details about how I used NodeXL to do this. I teach you how to do it in this article. So for that reason, I do commend it to you. This is just a tiny detail of the network, and you can see Alexandria in blue there. I'm using colors for different clusters within the network. And one of the things I just love about NodeXL compared to all the other software that I've tried is the artistic benefits, the aesthetics of the sociograms themselves. So again, following Ben Schneiderman's wisdom, I'm thinking to myself, what are some great questions that are relational? That is, what can I ask that shows Alexander with people, with places? And so I asked, just what do we get from the ancient sources of his relationships with all the people that he conquers, going west from Macedonia and Greece up down through Asia Minor, into the hinterland towards Ankara, the capital of Turkey today, going down towards Syria, Aleppo, the land of the Phoenicians, Tyre and Gaza, and into Egypt and becomes Pharaoh, and then up and through Syria again into Iraq, and then Iran, and then Afghanistan, Uzbekistan, Tajikistan, and Pakistan, and then back to die at the tender age of 32 in Babylon. So let's take a look. Using the clusters in a box, which I really enjoy, and using spirals, I was able to show that on the left, the most people he has engagements with are Macedonians in blue, but second are the Persians in the kind of lighter green. And then on the far right, the slightly smaller green, are Greeks. And below, in yellow, are Indians from Pakistan, and then it goes on to smaller groups. I think there are some 25 or something in all. The network as a whole has 404 members, nodes, people, and 1,052 ties between them. Another project that I worked on later was Socrates. I told you that I did the keynote in 2014, but I continued to work on it, and it got published finally in 2019 in at the Center for Hellenic Studies Research Bulletin that you can see at the bottom of the slide. And here what we're looking at is an animated GIF that shows Socrates and all his relationships, but then, which is about 144, something like that, but then the smaller clusters within the larger framework. So this is the whole network, then the clusters within the network, and the individual roles themselves. So then the question again is, how are women integrated into this very male world that we read about in Plato? And let me say an aside here, which is one of the great strengths of the digital humanities, of computational humanities, and of social network analysis, is that it helps us remember things we could not possibly keep in our heads if we were to just read Plato cover to cover. We couldn't remember the roles of all of these different people and how they're situated in their clusters, could we? So this is a great advantage. And in my teaching, when I have the opportunity to mentor someone in their senior thesis, if I have them do a social network analysis of just a small person or a biography or chapter of something, that student is the first person in the whole history of the planet to have ever done that. It is original research. It's extremely exciting to introduce to undergrads. So for Socrates, one of the other questions is, did he have relationships with the sophists, which he was accused of in Aristophanes and finally on trial at the end of his life? So I decided I would assign the different individuals or nodes into groups. These are not clusters that we learn of through quantitative algorithms. These are groups that I have created, that I've assigned people to roles of philosophers or students and so on. And so we do see that Socrates has some relationships with sophists there in green on the right, but also with foreign philosophers that came to study with him or be in his milieu, their students in yellow at the bottom, intellectuals who are like politicians and writers and playwrights and that sort of thing, the Socratics who were his students and are his closest friends. But the largest of all are none of the above. They're just people that he loved to talk to, or were parents of students, that sort of thing. So did he have relationships with the sophists? Yes, but the sophists had relationships with all of these others too. It's not just one way. So again, I'm using an animated GIF to demonstrate these ties between all of these different circles. So to sum up, we are bringing quantitative data to the humanities. We're allowing patterns to be seen that could never have been seen before through data visualization, that is, for us, making sociograms. And we are seeing familiar texts in new ways as a result, and asking new questions and making discoveries that really no one's ever seen before. It's a very exciting field to be in at this time, but always looking to shed light on relational questions. So let me give you another example. This is just two basic parts of paragraph, okay, about the Periclean building program. Archaeological, artifact today, still on the Acropolis. How did they build it? That's relational. What were all the different crafts that were involved? What was the relationship between humans and the materials? This is relational materiality, we call it. So the materials to be used were stone, bronze, ivory, gold, ebony, and cypress wood. The arts or crafts which should elaborate and work up these materials were those of carpenter, molder, bronzesmith, stonecutter, dyer. So you can see we're talking about things, material things, and the people who were using them. So I made an edge list with the material and who was working on them. And that's sort of a sample of what that edge list looked like. And when I put it all together, I could see it as a kind of machine, a kind of clockwork of interdependent things, people, and places as well. That is, transport was required to get some of these materials from the port of Piraeus up to the Acropolis, from the quarries up to the Acropolis, and so on. So I published that in 2018. It's a very small passage. Now compare that to what NodeXL is designed for social media, and you'll see, at the micro level, we can still squeeze out quite a lot of information. But at the macro level, from at least our scale, this is the pottery that I discussed earlier, the vase painters and potters. And we studied two different styles or techniques that were being used. First, the black figure vases, and then the red figure vases. And we have very large number of people, of artists, and it's multiplex, so we have pots in their shapes as well. One of the things, again, to use in NodeXL is to play around with having no labels. That is, removing these names that are kind of mesmerizing, and the colors too, which are my clusters, and instead simplify black and white, just using these spheres, and see what you see. How are these different groups tied together? Where are the hubs, and how are they getting across the network? So when you see it without labels, you then find something worth studying. What is so interesting? How, what catches your eye? This is a whole network kind of question. And then once you're down in there, then you'll see these different clusters, and you'll say, that purple one is really interesting. Look how it connects both to the blue and down to the lighter blue, and so on. So you begin to play with that middle ground, and finally see who it is that you're looking at, so that you let the sociogram guide you in your research. And finally, you go to interesting people. So the Liagros group is one of those nodes. And here you see the Liagros group and the second degree, and then the third degree going out. So plane, first degree with their ties, second degree, and then third degree, the kind of influence shaping that's going on. But I don't think I would have picked out this person, or this group, I should say, this node, without first having done the work without any labels. So the types of questions are relational. They're at the top level, the whole. What are the clusters and groups? How tight or loose are their ties? The individual, how are they serving as bridges or hubs? And then we look at the statistics, and I haven't mentioned that much. I've shown you a few samples. You'll learn a lot more about that in other places, but these centrality metrics are very interesting for, at the individual level, for really understanding and learning new things about the society that you're studying. Finally, I'm going to just briefly talk about the small world type of network. It's the most efficient, it's the most satisfying to be in and to study, because information and news and innovations all are sort of able to travel through the network in very exciting and fast ways. So let's just take a look in, again, the black figure vase painting. We're looking for patterns, for anomalies. And what I did on the right, you can see I sorted from highest to lowest in between this centrality. Who are these people who serve as these brokers or bridges that help you get from one place to another, that are along the shortest path inside your network? And so some, if you see who they are on the far left, number 3, row 3 is your first person, and that's actually a node that is a vase shape, little master cups. 4th is a vase shape, the amphoras and hydrias. 5th, the trefoil olpies, again, shapes. Lekithos painters, oinakoi, trefoil, these are again vase shapes. And then you get human beings in row 9 and 10. Nicosthenes is one of the most famous potters and painters, well known. But the cactus painter comes out of nowhere. I've studied, Greek vase painting for like 40 years and I'd never heard of him. So you can see him in light red here, the cactus painter, and he has an extraordinarily small number of degree centrality. That is, he only has ties to 3 other entities. Let's dive in there and see. He's connected, you can see in red, the cactus painter is here in the middle of it. He's connected to one shape called the red-bodied olpe. The Priam painter is his other tie. And the third is a kind of shape again, a lekithos. So that's it, which is kind of extraordinary that he has such a high reputation. And so we talk about it in our article and try to explain it. This is an example then of being able to see something you would never know or be able to see in any other way except through social network analysis and using these statistics. So let's go now quickly to the small world phenomenon. This takes a little bit more math. There isn't a button you can press on NodeXL that will tell you, yes, you have a small world network. You need the power law, that is, that you have a few individuals with extremely high scores and then a long tail with people who have 2 or 1 tie. You need an average geodesic distance of about 3 hops to get anywhere within the network. The maximum generally is 6 or 7, so that you're talking about 6 degrees of separation in popular terms. You will have an abundance of hubs. These tend to be the power law people, but not necessarily. So that there's a lot of tight-knitness, which we call graph density. So we're just going to be looking at this statistic right now for my ancient work. We're looking then at trying to see if the statistics show that we have an average path length or geodesic distance of about 3 or under. I'm going to start with a piece we published in 2015. This goes back even 1,000 years earlier than the ancient Greeks. They're clay tablets written in cuneiform, which were found in Egypt, but were correspondence between pharaohs and the vassal states throughout the Near East, going out as far as Iraq and Babylon. So we have 246 vertices with 464 edges. Here I've used the kind of trick of making the size of each node relative to its degree, that is the number of ties that it has. So that huge blue thing, the king of Egypt, and all of the other relationships that it has. And then I've used color for clusters. So let's look at the Amarna letters. To study small world, it doesn't hurt to use the circle so that you can see that it has hubs, and you can kind of just get a feel for the density that's important. So here, what we find then is that the maximum distance, that is the diameter, is 8. It could take you from one end to the other end of the network about 8 hops if you're really peripheral. But the average is 3.2, which is very sweet. So we called it a small world network. Socrates, again, pretty big group and so many edges. So you can see how dense it is in the left in the circle, right? Socrates being the red. So we look then at the maximum diameter. It's 7 hops between anyone to anyone. But just 2.899 is the average, which is very satisfying. 3 hops, under 3 hops to get anywhere, because you can get to someone who can hook you up. The red figure vase painters network. Here we have 13 connected components. So you can see without the labels, the very large component there, which is the main one we study, but then these other peripheral ones. And I, again, am using the very useful layout of clusters in a box for this. So we have 13 connected components, and that means, and what we're seeing there, I should say, in the oval is just the biggest one, is that one on the left there. So what we're seeing then is a diameter of 23. That is, it would take you 23 hops to get from one place to another, but mainly because how is one of these people in one of these tiny little clusters out there on the right ever going to get across the Great Sea to reach someone at the far end of that big component? So 23 is the way it's calculated, but really it's almost impossible to get over there. And the average geodesic distance is 7.78. So with metrics like these, you might be thinking to yourself, that there is a failure. That was 2 years wasted. And I might have agreed with you had I not gone back and asked this question: what would it have taken for this to be a success? How could I bring those numbers down from 23 as a maximum diameter down to something like 7 or 6? What would it have taken? So let's go back and look. Could we find more data somewhere that would hook together a component like this, like just give this one node some sort of connection to that node, or the hub, link that to another hub? Is there a way to tie these together somehow to bring them all in, this long sort of animal-like shape? Can we bring it on over somehow? So what it's really telling me is I just need a little more data, and you might too. Go back to your archive, go back to the library, try to find something that will connect these, and that would bring down that maximum distance instantly. If you could hook all of these into the main component, now you're talking, right? So don't give up, but understand that sometimes we just don't have enough data and you're just not going to get there. And that's the nature of the humanities and of the digital humanities too. You're going to have successes, you're going to have failures, you keep going. So thank you so much for your attention. I hope you've learned a little bit about the study of social network analysis in the humanities and this very exciting time that we're in for historical network research. And I sure wish I could be with you there today to talk more about it. But thank you.